A very good morning. From today onwards, I will cover the topic of mathematics of class 11, and I will start from coordinate geometry. Okay. The syllabus that are included in coordinate geometry are I have written straight lines. Second one is conic section, and third one is introduction to 3D geometry. Now I will start from straight line. The topics that are included in straight line are as below. First one is recall of 2D geometry that you have learned in class 10. Second one is shifting of origin, slope of a line, angle between two lines, various forms of equation of lines, general equation of line, equation of family of lines, and the last one is distance of a point from a line. So if I subdivide that every part, then in the topic of recall of 2D geometry, we have the points. First one is Cartesian coordinate forms. The second one is distance formula. Third one is section formula, and the last one is locus and equation of locus. Okay, that's fine. So I will start from Cartesian coordinate system. So then let's begin. If I say what is Cartesian coordinate, then I must have to say that all of you have learned in class 10 that we have two axes, basically this and this. We named it x o x dash and y o y dash. Basically, x o x dash and y o y dash are two mutually perpendicular lines through any point O. So this is Cartesian coordinate, and if we want to find any location of any point P, then we use this two-dimensional Cartesian coordinate system. So suppose here are the marked lines denoted by 1, 2, 3, 4 and 5. Here also 1, 2, 3, 4. Okay, so let assume I am in the origin, so I have to move to point P. So how can I move? I have first move in x-axis from 0 to 1, then 2, then 3, and then I have to go upward, that is 1, 2 and 3. So first I go in the right direction of x-axis, that is in the positive direction, and then I have to go to upward direction in the y-axis. So then I have the position of the point P. So this is the position 3, the position from origin in the x-axis, and y, that is also 3. So in Cartesian coordinate system, we have the location of the point P like that, 3, 3. In 3 it is called abscissa, and second one is called ordinate. Sorry. Abscissa. Okay, and 3, 3, this order pair is called the coordinate of point P. Okay, then I have covered the Cartesian coordinates, and now let's go to the quadrant section. In this Cartesian coordinate we have 4 quadrants. This one is first quadrant, this one is second quadrant, this one is third quadrant, and this one is fourth quadrant. In the first quadrant, all the values of any point which is in the first quadrant having the coordinates which is x greater than 0 and y greater than 0. All the points which are in the second quadrant having the coordinate which is x less than 0 and y greater than 0, because the coordinate of any point which is in the second quadrant having the abscissa which is in the negative direction of the x-axis and ordinate which is in the positive direction of x-axis. So it is x less than 0 and y greater than 0. In the third quadrant we have to move in this region, so any coordinate of point P will be x less than 0 and y is also less than 0, and any point in the fourth quadrant will having the abscissa x greater than 0 and y less than 0. So basically we can say that in first quadrant it is plus comma plus, that is the sign of abscissa and ordinate. In second quadrant it is minus comma plus, in third quadrant it is minus comma minus, and in fourth quadrant it is plus comma minus. Okay, so far we have discussed the coordinate Cartesian coordinate system. Now coming to the distance formula. Okay, basically what we did in distance formula is we find the distance between 2 points. Let us assume P x1 comma y1, and this is point Q, that is x2 comma y2. So what we did in distance formula, we basically find the distance d between 2 points which is also in the Cartesian coordinate system. So what is the formula? That is d equals to pq, that is the distance between 2 points, is equals to the, first subtract the abscissa and then square it, and then plus the subtraction of the ordinate and the square. That is, we have first subtract x2 minus x1 whole square plus y2 minus y1 whole square. That is, in general, if we say this is the difference between abscissa whole square plus difference between ordinates, its whole square, which is whole root under. Okay, then taking an example, we are given 4 points such that a 0 comma minus 1, b 8 comma 3, c 6 comma 7, and d minus 2 comma 3. They have said that we have to show a, b, c, d are the vertices of a rectangle. Okay, then assume this is an rectangle. Okay, which a have 0 comma minus 1, b have 8 comma 3, c have 6 comma 7, and d have minus 2 comma 3. These all are the coordinates of A, B, C and D. Okay, then to find the to find that this is an rectangle, first we have to find out the distances between A and B. Okay, what is the distance of A and B? Let write the formula first. X2 minus x1 whole square plus y2 minus y1 whole square. Okay, then what is the distance between A and B? It will be 8 minus 0 whole square plus 3 minus of minus 1, that will be plus whole square. It will be 8 square 64 plus 4 square 16. It will be 4 root 5. Give the unit. According wise, BC will be root under 8 minus 6 whole square plus 3 minus 7 whole square. It will be 2 square plus 4 square. It is 4 plus 16. This will be 2 root 5. Give the unit. Likewise, CD is 6 minus of minus 2. 6 minus of minus 2, it will be 6 plus 2. Okay, 6 plus 2 whole square plus is 7 minus 3. It will be 8 square plus 4 square, that is 4 root 5 unit, and ultimately dA. To find the dA will be minus 2 minus 0, this minus 2 minus 0 whole square plus this 3 minus of minus 1, that is 3 plus 1. 3 plus 1 whole square, it will be 2 square plus 4 square, it is also 2 root 5 unit. Now if we look carefully, we have AB equals to 4 root 5 unit and also CD also 4 root 5 unit. That means AB is equals to CD. Then if you look BC, it is 2 root 5 unit, and DA it is also 2 root 5 unit. Then these two are equal. I want include one thing, that while finding the distance, if we take x2 minus x1 or x1 minus x2, it will not hamper because there is a square, so don't think about it very much. Okay, here we have AB is equal to CD and BC is equal to DA. Okay, so we can say that this is a parallelogram because the opposite two sides are equal, and the opposite these two sides are equal, so this is a, therefore ABCD is a parallelogram. Now we have to prove that this parallelogram is a rectangle. Okay, so what will be the property? Say this is a parallelogram. Okay, this is special type of parallelogram because it's this angle all are having 90 degree. Okay, so what we can say that if a parallelogram having all the angles are 90 degree, then it will become a rectangle. Okay, so Now we have to find the distance between AC. So what is the distance between AC? AC is 6 minus 0 whole square plus 7. Okay, it will be 6 minus 0 whole square plus 7 minus 1, that is 8. 7 plus 1, 8 whole square. It is 36 plus 8 square, 64. It is 10 unit. Okay, so we can say that AC square is equal to AD square plus CD square, because AD square equals to what we have. AD is 2 root 5 unit, that is 2 root 5 whole square, that is 2 square 4 into 5, 20 unit. And CD square, CD is having 4 root 5 unit, that is 4 root 5 whole square, 4 square 16 into 5, 5 16 80, 80 unit, that is AD square plus CD square is equal to 20 plus 80, that is 100 unit square. Sorry, it will be square. Okay, then it is 100 unit square. And also we have AC is equal to 100 unit, that is it is AC square, that is because 10 square is 100. Okay, now we have proved that AC square is equal to AD square plus CD square. Similarly, we can have BD square equals to 100 unit square, which is equals to CD square plus BC square. You can check it also. This BD square is equals to BC square plus CD square. So at last we can conclude that this ABCD parallelogram is a rectangle. Hence it is proved. So in today's class we have covered these two topics, and in the next session we'll discuss about the section formula and locus and equation of locus. Okay, thank you.